Welcome to our Operation Research Summary Discussion Point. በዛሬ ሴሽናችን ላይ 20 ፒፒቲዎችን ወይም ደግሞ ስላይዶችን ሼር የምናደርግ ሲሆን እያንዳንዱ ስላይድ ላይ ያሉትን ኪ ፖይንቶች በትኩረት ማንበብና መከታተል ይጠበቅባቸዋል ማለት ነው። ወደ መጀመሪያው ሴሽናችን ስንሄድ ኦፕሬሽን ሪሰርች ምንድነው ተብሎ ዲፋይን በሚደረግበት ጊዜ ኦፕሬሽን ሪሰርች is primarily concerned with scientific decision making የሚለውን ፖይንት መያዝ ይጠበቅብናል። And in the operation research graphical method የሚባል ቴክኒክ አለ። This graphical method technique is used in linear programming to solve optimization problem by plotting constraints and identifying the feasible region on a graph. ስለዚህ እዚህ ጋር the key point is that the graphics method is suitable when two decision variables exist. Okay, so we have to consider that there has to be two decision variables existing so that we can use graphics method. The other one is in the graphical method there is a feasible region. This feasible region is the area on a graph where all constraints of linear programming problem are satisfied simultaneously. ስለዚህ feasible የሆነው region ወይም ደግሞ ያዋጣል ተብሎ የሚታየው region በከለር የተቀመጠው region እዚህ ጋር የምናያቸው regionዎች ምንድናቸው? linear programming ላይ ሁሉንም ፕሮብሌሞች ምን የሚያደርግ ሳቲስፋይ የሚያደርግልን ነው ማለት ነው። ስለዚህ the feasible region is the area satisfying all constraints ሁሉንም ኮንስትሬንቶች ሳቲስፋይ የሚያደርግ ኤሪያ feasible region ብለን ዲፋይን እናደርገዋለን ማለት ነው። When you come to optimal solution in linear programming, the best value of the objective function is usually found by evaluating the corner point of the feasible region. ስለዚህ the optimal solution occurs always at corner point የሚለውን ኮንሲደር ማድረግ ይጠበቅብናል ማለት ነው። So the optimal solution occurs at a corner point. The other one is the slack variable. As you remember, slack variable is introduced in linear programming to convert an equality constraint into an equation, making it easier to solve using the simplex method. So this slack variable is represented or added to less than or equals to constraint. So slack variable is added to let down or equals to constraint which ያሉበት ላይ ነው ማለት ነው include የምናደርገው። The other complex method that we discussed about is simplex method. The simplex method is an iterative procedure used to solve linear programming problems by moving through feasible solutions until the optimal solution is reached. So the simplex method moves from one basic feasible solution to another ማለት ነው. So why do they move? So that we can get an optimal solution ማለት ነው. So simplex method moves from one basic feasible solution to another. The other one is entering variable. In the simplex method, the entering variable is chosen based on its potential to improve the objective function value. Here the key point is the entering variable is selected from the most negative indicators. Alright? The entering variable is selected from the most negative indicators. The other concept we discussed is duality. When you talk about duality, it is an important concept in linear programming where every optimization problem primal has a corresponding related problem called the dual. So duality relates primal and dual problems. So when we talk or when we ask about duality, we need to relate them primal and dual problems. The dual transformation provides another perspective on the same optimization situation and helps verify optimal solutions. So the key point here is that the dual of maximization problem is generally a minimization problem. Okay, so if there is a dual maximization problem, it is generally a minimization problem. The other is the structure of duality. When forming the dual problem, the role of constraints and variables are exchanged according to duality principle. In duality, constraints become what? Variables. Alright? In duality, constraints become variables. The other point we discussed about is the transportation problem. A transportation problem deals with determining the most economic way to transport goods from source to destination. So, a transportation problem aims to minimize transportation cost. Okay, if we are asked what's the transportation problem, its aim is to minimize transportation cost. A transportation problem is balanced when supply and demand are equal. Okay, when we are asked when is gonna be a transportation model be balanced, we need to focus on balancing is happened when supply equals to the demand. The other concept is the northwest corner method. In the northwest corner method, a simple procedure used to generate an initial solution for transportation problem. Okay, it is a method that we use in order to generate an initial solution for a transportation problem. So the northwest corner method provides an initial feasible solution. It should be our first thought. The other concept is VAM technique. The VAM is a transportation technique that often produces a better initial solution by conducting penalties cost. Okay, so VMA stands for Vogel's approximation method. The key point that we need to focus on is the abbreviation VAM stands for Vogel's approximation method. The other concept is assignment method or the assignment problem. The assignment problem involves allocating resources such as workers, machines, or tasks in the most efficient manner. So assignment problems are usually solved using the Hungarian method. The approach that they use assignment problem is the Hungarian method. The other one is work task allocation. Each worker is assigned one job. When you talk about this work task allocation, the main concept is that each worker is assigned to one job. When we come to the decision theory studies how choices are made when outcomes are uncertain and information may be incomplete. Decision theory deals with decision making under uncertainty. Okay, decision making deals with decision making under what? Uncertainty should be our main focus. The other one is maximization criteria or maximax criteria. The maximax criteria is optimistic. Okay, the maximax criteria focus on selecting the alternative with the high possible payoff and reflect a positive outlook. So the maximax criteria should focus on what? Optimistic approach. This approach, the maximum criteria, in reverse, they focus on what? The pessimistic approach. The maximum criteria focus on the best of the worst